What is the role of cryolite in the metallurgy of aluminium? Well, what do you think? What possibly could be the role? Well, the role is very simple. Aluminium is extracted from bauxite, which is Al2O3, which has very high melting point, around 2200 degrees Celsius. Let me remind you, iron melts below 1600 degrees Celsius. So, how would you heat that? Because normally heating is done in iron vessels. Now, at such a high temperature, you find Al2O3 itself iron itself would melt. There is no vessel in which you can melt it easily. It becomes very expensive. So, the role of cryolite. And what is cryolite? Cryolite is Na3 AlF6. It is cryolite. It is a mineral which was found in Greenland, and nowadays people synthetically prepare this. The beauty of this is cryolite has a melting point of around 1200 degrees Celsius only. Right? So you just heat it to 1200 degrees Celsius, cryolite melts, and it can dissolve Al2O3. Like sugar dissolves in water, Al2O3 can dissolve in molten cryolite. And not just that, it is a strong electrolyte. What does it mean? You can pass current through molten cryolite. That means you can conduct electrolysis of molten cryolite, and if you have Al2O3 dissolved in molten cryolite, Al2O3 can be electrolyzed, and that is very, very beautiful advantage. And one more advantage, it is inert, non-volatile. What does that mean? See, as a solvent, it is very useful if cryolite itself does not react. It just facilitates the reaction of aluminum oxide. On its own, cryolite is not reacting. It is not evaporating. It is not changing. So nothing can be as good as this. You just take some cryolite, melt it, you dissolve alumina, and as a matter of fact, if you dissolve lots of alumina plus fluorspar or CaF2, the melting point can come down to as low as around 900 degrees Celsius, which is very, very convenient. Conduct electrolysis. That is beautiful. That is why cryolite is used very popularly in metallurgy of